Hi guys, today we will describe a decorator pattern. So let's jump into it. So first we'll define it and then we will focus on the practice. So we'll actually implement decorator both in the object oriented and the functional style. So let's start with my definition of this pattern. So a decorator is a pattern that allows us to augment the behavior of the object or a function without modifying them. That's first. And in the object-oriented case, an object implements some interface and holds a reference to another object, which also implements the same interface. Obviously, you can do the same with the class or just base type. And the decorator object then delegates a function call or calls to a held reference and adds new behavior before or and after function call or calls of a held interface. And a similar behavior can be achieved using just functions. So, what we have here, I have prepared a simple interface which I called page, and it has one method, render. So let's firstly to show and implement the decorator pattern, we need to have at least one other implementation of this interface. So let's create something simple like in memory page, which will implement this interface, and it will just render page from the memory. So it will just return page, and we need to create a constructor. Alright, let's initialize it, and let's maybe give it just some page, and for the sake of readability, let's call it base page, and let's just see that it works. Alright, so this is our base implementation or first implementation of page interface. And right now we create a first decorator. So as we have established, the decorator always implements some interface, and it holds a reference to another object which also implements the same interface. So we need to have another definition of page, another implementation of page interface that will hold page interface, and it will delegate the calls to it, but it will also add some behavior to it. So let's create, for example, logging page, and it will have a reference to a page. Also implement it. What we will do, we just log something before and after rendering the page. So let's just say about to render page. Here we'll call the reference. We return the page rendered by base implementation. We say page rendered. Maybe let's add a new line. And how we are supposed to use it is like that. We create a logging page, and what's important is that it needs to have another implementation of the page interface. So we give it the base page, and we will call it like previous, and it will return the same. To return the same page, but with the added behavior of logging. So this is basically a decorator pattern. Let's maybe create one more decorator. So you can create something like, let's say, throttling page. It will also implement page, and it will throttle requests to rendering a page. So it will just sleep some amount of time before rendering a page. So let's say that we give it arbitrary delay. Just create a constructor. Say page equals page, delay. And here we'll just sleep. And then we return page. And we need to catch exception, and let's retro it. No problem. Tracking page. Alright, and let's use it. And let's say that we want to wait 1 second before it. So now what we should see is this segment will be the same, but after it we will wait 1 second before rendering next page. Yeah, it was like that. Alright, so we have 2 decorators, which is logging page, logic page. Each of them has another implementation of the page interface. Then one more important thing is that we can combine decorators in an arbitrary manner. So we can say, for example, that we want to have logging throttling page, and we basically create a logging page, but it will have a reference to a throttling page. So it will log a message before rendering a page, but it will also throttle the rendering. So we have 2 additional behaviors thanks to that. So it's pretty flexible when you think about it. Yeah, so as you can see, it's probably also interesting alternative to subclassing or subtyping, because you don't have to extend anything. You can just implement the same interface, delegate the call, and add new behavior to it without actually changing the code from the implementation on which you are relying, because all you need is a base implementation of this interface. Right, so let's actually comment it, because I said that we can also have can also achieve similar effect using just functions, so in a functional style. So now we do just that, but let me do something here. Let's say this parameter is to go, and let's do something like that. And here we will implement the same code but using just functions. So let's say let's create first function, maybe here, and call it render page, and it will render some hard-coded page. And just actually copy the code from here. But instead of that, we will just say something like that. So a function. So we just use supplier and here we say get. Say false. Okay, so this is our base function, and right now we want to have logging page, but just as a function. So what we can do is to say that we want to have render page logging, and we want to, and what is crucial here is that we give render page function as an argument. So all we need here the function. This will be the same, but here we will just call function that we have received. And basically, it will work the same as in the object-oriented example, but instead we will use suppliers, just function without argument. We say logging page, render page, logging. Here we can base page. Right, so let's implement also throttling page. So render page throttling. Same as previously, we need to have reference to function and delay, but as a function argument. And let's copy the code from here. Okay, and let's copy that. Here we need to have a supplier and obviously function. So render page throttling, and it will work in the same way. And the last one is combined one, so logging throttling page. So previously supplier, and here we need to say render page logging, and as a base function we give it throttling page. And let's call get. Yeah, and as we can see, we can actually have the same behavior using functions. Obviously, We don't have state here because if we were to, I don't know, implement something like caching page, we need to have a field and it will be harder, but we can actually implement most of the design patterns, object-oriented design patterns, using just functions or functional programming. So that's it, guys. See you next time. Take care.